Hello everyone, this is Jason Balatbat and I will discuss this problem solving using mathematical investigation and modeling technique. So the problem is, 2 points are placed on the same side of a square. A segment is drawn from each of these points to each of the two vertices or the corners on the opposite side of the square. The question is, how many triangles of all sizes are formed? Using Poly's 4 steps, Step 1. Understand the problem. There are some conditions that we need to satisfy. First, 2 points are on the same side of the square. Second, a line segment drawn on those points to each of the corners on the opposite side of the square. Step 2. Devise a plan. For this, we need to draw a picture or illustrate the given problem. Or we can use look for a pattern and use a variables. Step 3. Carry out the plan. So first, we need to draw the figure, which is square. And remember the conditions. First, 2 points are on the same side of the square. It can be here on the left side, or it can be here on the right side. Second condition, a line segment drawn on those points to each of the corners on the opposite side of the square. So we need to plot the 2 points and draw a line segment. And we draw the bigger picture or bigger illustration. This is the point A, point B, point C, and point D. On the first point, or the point A, we have 3 triangles were formed. The triangle ABE, triangle BCE, the triangle CDE. On the second point, which is the point F, and the intersection point G, we have another or additional 9 triangles, which are the triangle ABF, BEF, BEG, EFG, CDE, CDF, CFG, BCG, and CFE. So the total triangles were formed are 12. So what if we have more dots plotted on this figure? So we need to look a pattern. So we need to separate the triangles in the top, bottom, right, and left. So this is the point W, point X, point Y, and point Z. On the first point, we have on the top, 1 triangles were formed. On the right side, we have 1. On the top, or on the bottom, is 1. And from the left is 0. So since the top and bottom are symmetrical, they have both same triangles formed. So on the first point, we have 3 triangles were formed. On the second point and the intersection point A, so in the top, we have 4 triangles. The 2xy, 21y, a1y, and a1y. So on the right side, we have additional 2, which are the 2yz and ayz. So again, on the bottom, we have 4 again. On the left side, or on the bottom, we have 1wz, 2z, 2az. On the left side, we have 1 triangle, which is 2a. On the third point, or in the second point, we have 12 triangles were formed. On the third point, on the top, we have 10 or additional 6 triangles, which are 3xy, 31y, 32y, b2y, CAY, and C1y. On the right side, we have additional 3, which are the triangle 3YZ, BYZ, and CYZ. So again, the bottom, we have both same triangles, which are 10. On the left side, we have additional 1, which is the 2, 3B. So in the third point, we have 28 triangles formed. On the fourth point, on the top, we have additional 10 triangles, which are 4XY, 41Y, 42Y, 43Y, D3Y, EBY, E2Y, FCY, FAY, and F1Y. On the right side, we have additional 4 triangles, which are 4YZ, the DYZ, EYZ, and FYZ. On the bottom, so they have the same on the top, which are additional 10. On the left side, we have another or additional 1 triangle, which is 3,4D. So in the fourth points, or in the 4 points, we have 53 triangles were formed. On the fifth point, on the top, we have additional 15 triangles, which are 5XY, 51Y, 52Y, 53Y, 54Y, G4Y, HTY, H3Y, IEY, IBI, I2I, JFY, JCY, JAY, and J1Y. On the right, we have additional 5, which are 5YZ, GYZ, HYZ, IYZ, and JYZ. So on the bottom, we have the both same, the top. And on the left side, we have additional 1, which is the 4, 5G. On the fifth points, we have 89 triangles formed. So the formula in the top and bottom is n multiplied by n plus 1 multiplied by n plus 2 all over 6, or the sum of the triangular number sequence. On the left side, we have the n multiplied by n plus 1 all over 2, which is the triangular number, and on the left side, we have n minus 1.